Now we have started recording.
There wasn't a lot.
Hello, Landon. Hope you're enjoying this. Whoever else is absent today.
Landon, come back.
Landon's not going to watch the review video. Are you kidding?
So what should we let you be?
Atlanta.
Yeah, almost always. Especially if there's an X in the bottom. That's
Or if there's something uglier going on.
because there's DU is right.
But what do we do about the F prime?
You're good.
So let's
Freaks me
see.
out.
Integral antiderivative of f prime of u du, right? Because 1 over x dx is the du. I do need to be careful about the limits, right? Because those are x values, and I'm switching to u values. So I need to get u of e squared,
Which is ln.
natural log of e squared.
Which is what?
Is it 1?
Not 1. Natural log of e is 1.
2. Is it 2?
It's 2. And then u of 1 is the natural log of 1, which is 0. So I've switched this from ugly natural log stuff to, well, it's still not great maybe because I don't know what f is.
Well, we're taking the antiderivative of f prime.
So what's the antiderivative of the derivative?
It's just that.
It's just f.
F of a or f of b minus f of a.
Mm-hmm. Yeah, f of u from 0 to 2, so f of 2 minus f of 0.
Which is why you gave us all that crap.
Which is why I gave you all that. Which is why I gave you all that stuff. Some of it extra information. F of 2 is 5. F of 0 is negative 2. So my answer is 7. So that's the kind of thing that there's a lot of steps in there. Like no one step is really that terrible. It was clear what u should be. Change the limits. Antiderivative of derivative. That's you. In some ways you can't get any easier than that. But did you recognize that? And then were you able to plug in 2 and 0 and pick out the right spots? It's a lot of stuff. A lot of places to mess up. All right. How about questions from worksheet 6. Thank you.
4.
Worksheet 6, number 4. Let's see. So, looking at number 4, worksheet 6, a couple things I'm thinking when I see that for you.
Is yuck.
If I try 1 minus t to the 4th.
That's the square root of.
So not the square root thing. I know that would be too much. But if I try 1 minus t to the 4th.
Well, negative 4t to the 3rd.
I'd get negative 4t cubed. That's, no, that's no good.
Wait, but I recognize arc sine.
But it does look a little bit like arc sine. Arc sine is a squared minus u squared.
Mm-hmm.
So what would u need to be to make arc sine work?
T
There needs to be
squared.
t squared.
If u is t squared, then u squared would be t to the 4th.
Yep. Du is 2t dx.
Well, dt, but
AT.
do we like that for a du?
I change.
That's great news. All he needs is a 2 and a 1/2.
And then a equals 1.
A equals 1, if you want to put that in there. So 1/2 antiderivative du over the square root of a squared minus u squared. That's exactly arc sine. But you couldn't have gotten there unless you sort of recognized arc sine from the get-go and started walking that path. So I don't know that I would have seen arc sine originally. I was used to plugging in the denominator for you and hoping it worked. It didn't. So I had to switch to an arc sine thing. 1/2 arc sine u over a, t squared over 1. That's a little unnecessary, but it's okay. Plus c. So a lot of these are about recognizing what's going on. Haven?
So I have a question, like just in general. So for arctangent, on 5 and 6, they're both arctangent. But whenever I was picking which one was A and which one was U, like I think on the like in the notes, I want to say it was
It's
U
U
squared
plus A squared.
U squared plus A squared, but then on 6 it was backwards. So I don't know how to like why is it like that.
Right. So a couple things. One, I mean, I guess the obvious thing is like it's addition, so it doesn't matter.
Yeah.
But u is always the variable thing. A is the constant. So that's how you can know that a needs to be square root of 7. On this one, over here, a would be 5.
Okay, so whenever I'm picking like which one's A, just pick it as the constant.
Yes.
Okay, I didn't know that.
Yeah. And I remember it either way, and so when I'm doing these the first time through, I don't even remember which way I presented it, but I try to do it the same way, but it doesn't matter.
Yeah.
It's commutative property.
I mean, not wrong, but yes. Do we need to do 5 or 6, or are those okay? They're both arctan.
Yeah.
Just don't forget that arctan has the extra 1 over a out front. 6 would be a little bit like number 4 in that you'd have a 2 as well. What else? I'm more worried about like number 8.
Mm-hmm. Number 8.
So again, it's got to be a u substitution of some sort. If u is e to the 2x plus 1, then du is e to the 2x times 2, and that doesn't do anything for me.
Well, you could put a 1/2 out front.
Yeah, but that didn't. I mean, I can always fix the numbers. I think this sort of looks like something squared plus 1 in the bottom.
Yeah.
So that's an arctan kind of thing.
Mm-hmm.
So if u is e to the x, du is e to the x. So this is kind of tricky because this numerator e to the x, I could say it's u, or I could say it's du. Either one.
I think we should do the
I think we should do du, because then I have du over u squared plus 1, which is arctan. Let's fix our limits though. U of the natural log of 5. So e to the natural log of 5.
5.
That looks awful, but it's just 5. U of 0. E to the, whoops, well, that's easy. E to the 0 is 1. So 1 to 5. Am I okay? Did I make a mistake?
There's discussing.
So now it's arctan of u over a, e to the x over 1, 1 over a out front. That's a little bit ridiculous, 1 over 1, but that's
just to check it off.
just to remind you and remind myself, it's 1 over a out there from 1 to 5. So arctan e to the 5th minus arctan e to the 1. And there is nothing further I can do with that. I don't know what that is.
Safe stop.
That is a safe stop.
Because
for
we
sure.
don't got calculators.
Nine or 10? I mean, are you to the point where you can look at them and recognize like where you're headed?
9 is kind of.
9 you just have to do square, right? Complete the square.
9 you do complete the square.
I think somebody got frustrated.
So I split that up into 9 and 4 to complete the square. And when you complete the square, now where am I headed?
Take the 3.
Arc sine.
Yeah, but bigger picture than that. You're right. I see a 3. And
Sine.
arc
Tan.
tangent. This is going to be an arc tangent problem.
Oh yeah, because there's no square root.
10 looks like an arc sine problem.
Yeah.
So a would be square root of 8. And u would be 5x. And there'd be a whole lot of 5s and
What's with
7s
seven?
and 8s that we'd have to fix. 7's an easy fix, though.
Yeah.
That would just go out front.
That's just kind of.
I mean,
So it'd be
I'm
7
cruising
over-
through those. I will happily stop and do one the rest of the way.
No.
Number 11, it looks yuck, but it also looks like big picture. What's going on number 11?
Arc sine.
Arc sine, because square root of 1 minus, or a squared minus u squared. So eventually that's arc sine. Number 12, that's another complete the square, which means, I was getting hopeful there. I could rule out answer choice A, but that's all I could do. $13 looks like arctan. 14 looks like arctan. 15 looks like arctan, because there's no square roots.
Alrighty.
You want to see any of those? 13? Okay, so I'm thinking arctan because it looks like a squared plus u squared in the bottom. So that's why I'm thinking arctan, maybe. So if u is e to the x minus 1, du would be e to the x. That's good news. So all of that is du over a squared plus u squared. I need to fix the limits. U of natural log of 2. So e to the ln2 minus 1 would be 2 minus 1. E and natural log cancel each other out. So 2 minus 1 is 1. So my upper limit is 1. U of 0.
Because it's 1 minus 1.
Plug in 0. 1 minus 1 is 0. So yeah, that turned into nice limits. 0 to 1. So 1 over a arctan u over a,
Which could just be.
from 0 to 1. Yeah, I've written that kind of weird now. So arctan of, oops, wait a minute. I did this on a video I posted, and I couldn't find the error, and I showed it to Miss Murray, and she couldn't find the error. And then like 5 minutes later, she came over. She goes, "I figured it out. I did this." What do you know what I've done wrong here?
You didn't put the u, you put the e and the x.
Yeah, I put e to the x stuff back in there, which would be okay
If you kept the x.
if I kept the x limits. So this is not right because this is x stuff, this is u stuff. So I'm just going to put the u back in like I should have done. So arctan of 1 minus arctan of 0. By the way, that is a safe stop because those are calculator ready. So if you got something like that on a free response question, you could leave it like that. Arctan of 1, that would be pi over 4. Arctan of 0 is 0. So pi over 4. I did not mean to make that mistake, but I'm glad I did because I made it on the video. So if you see me floundering along in the video at number 20, that's why.
Arctan is just the one, like, if it has arc in front of it, you can't go through quadrant 3?
Correct. Arctan comes from 1 and 4.
Yeah.
Yes?
Oh.
Anything else on 13? Go ahead.
On 8, on the review, there's sine split.
from x minus 1 over x to x plus 1 over x.
On the posted answers?
Yeah.
So is this not what I got?
That's what I got.
Okay.
The posted answer says...
We'll go with this because I did this. This is what I was about to say. During my conference period today, I worked all the evens on worksheet 7 on video. So yes, the answers are posted, but I worked them, me working them out, showing, talking, that sort of stuff. So apparently number 8 was wrong on the posted solutions, but I got it right this time I did it.